This video will show you how to test the high temp fuse and the heating element for a Kenmore 90 or Elite dryer that will not heat. Safety first, so always disconnect power before servicing any electrical appliance. And when taking these machines apart, remember that the inside edges and parts are very sharp and can cut you or cause serious injury, so be careful not to get cut. If you don't know how to take this machine apart to get to where you can do the testing, click here for the video that shows how to disassemble the dryer.
Okay, now that we've got the dryer disassembled, this dryer we're testing for heating problems on this video. So there's two things we want to test to see if it's causing it not to heat. Before we even do the test on them though, you want to verify and look at and make sure that all these wires, of course I've got the dryer unplugged before I even started disassembling it, so make sure you have your dryer unplugged. But making sure that all these wires are attached firmly, none are burnt off or disconnected or anything. Here you have your high temperature cutout fuse, you have your thermostat, this is the heat element casing, the heat element, here's the connections on them on the ceramic connector here. The heat element is actually inside there. So since we're testing for something that's causing it not to heat, we're going to use the ohm meter. These wires are tight. The first thing you want to do is remove at least one wire from the connector there. Usually you can, if it's a single item you're testing, you can remove just one. You can remove both wires from it as well, which is what I'm going to do. Make sure you're actually testing just the component. These are the connectors, like I said, for the heating element, so I'm going to test it first. The first test we're going to do is to verify and make sure that the heating element has continuity. So I'm putting my ohm meter on ohms, and I'm putting it down to the tone or continuity tester. So you get tone like that when you have continuity, okay? And really what we're testing for is continuity. You should have a very minimal readings on the ohms as well. You have continuity here on the ohm meter. When I test from pole to pole on the connectors for the heating element, so it's testing good, it's not broken. Then what I'm going to do is I'm going to remove one lead from one of them, leave the other one attached, and I'm going to check it to ground. You should not have, and this is a correct reading when it's good, you should not have any tone. Now I'm going to check from the other terminal just to be on the, make sure I catch from both ways. So this heating element is intact and it's not grounded out to ground either, which is what you want, so it's testing good. If you finish testing an item, go ahead and reattach both wires to it so you remember where your wires go. Okay, now I'm going to go ahead and test the high temperature cutout fuse. Again, remove both wires from the fuse, and I'm going to test from terminal to terminal using the same settings on the ohm meter, setting on the continuity tester. Okay, and this is good. Now I've got almost no resistance, which is what you want on that fuse. Okay, had some resistance. It didn't show it because it was higher than the range on the heating element, but that's fine. It's going to have resistance. There's almost 0.02 of resistance. It's very, very low, which is what you want. The main thing is, does it have continuity? Yes, it does. So it's a good fuse. If the fuse had been bad, or if the heating element had been bad, you would then change that component to fix the problem of not having heat. The other item that's on here is the thermostat, and you want to check it too, just to be on the safe side. It probably will have continuity unless it's broken or something inside it, and that will also keep it from working or having heat. Now, just because it has continuity, which I'm about to find out here. Okay, so it does have continuity, and it's good as far as continuity goes. That doesn't mean the thermostat is actually good, though. It just means it's definitely not bad. Or excuse me, it's definitely capable of working. The thermostat opens at certain temperatures and then closes at certain temperatures, and for it to be good it has to do that as well. So I don't have a way here to show you of checking it for temperature, but if you have no continuity, it is definitely bad, and you would have to replace the thermostat in that case. Now I have continuity here, I had continuity here, I had continuity here, so all these components are good, so none of them are bad, so none of them are causing it to not heat. So I'm going to go ahead and reattach all the wires back onto the terminals. Now, like I said, if you had a bad high temperature cutout fuse, that would keep it from heating, and you would just remove the screws that are holding it on here and put the new one on. The high temperature cutout comes in a bag with the thermostat. Change it at the same time. Sometimes when this fails, it's due to the thermostat not closing and opening at the right temperature, so you always replace them together. And it does come in a package together anyways when you buy the high temperature cutout fuse.